Welcome you all to the video lecture on signals and systems. Today we are going to system problem. In discrete time, whether the given system is linear or not, variant or invariant, causal or non-causal. So the given problem is y of n is equal to log x of n. So y of n is equal to log x of n. First thing we need to find out whether it is a linear or not, linear system or not. So your first step, we need to find out output due to weighted sum of input. We need to find out output due to weighted sum of input. That is your first step. So for that, what we need to find out means we have to replace y of n by a y1 of n plus b y2 of n, and we need to replace x of n by a x1 of n plus b x2 of n. So output due to weighted sum of input, for that y of n is replaced by a y1 of n plus b y2 of n, and then log function write as it is, there is no issues on that. X of n is replaced by a x1 of n plus b x2 of n. This is my first step. Second step, I need to find out weighted sum of output. I need to find out weighted sum of output. So for that, write your equation as it is, y of n is equal to log x of n, and replace y by y1 x by x1. That is, with the suffix 1 you write the equation y by y1 x by x1 and multiply the whole equation by the constant a. So left hand side multiply by a, right hand side multiply by a. This is the second equation. Third step, again write the equation as it is with suffix 2. So replace y by y2 and log will be there as it is, x by x2. Replace output y as y2, input x by x2. All other things will be there as it is, and multiply the whole equation by b. So I will be getting the equation 3 as this. Then add 2 plus 3. So a y1 of n, left hand side add all your terms, a y1 of n plus b y2 of n is equal to, add the right hand side terms. So a log x1 of n plus b log x2 of n. This is my fourth equation. Now compare first equation and fourth equation. Definitely first equation is not equal to fourth equation. I have similar term in the left hand side, but I have different terms in the right hand side. Okay, so the equation 1 is not equal to the equation 4. Therefore, the system is said to be the non-linear system. Therefore, the given system is said to be non-linear system. First step, replace y by a y1 of n plus b y2 of n, x by a x1 of n plus b x2 of n. Second step, replace all your equation y as y1, x by x1, multiply all the terms by a, and again third step, replace y by y2, x by x2, multiply all the terms by b, add 2 and 3, check whether the equation 1 is equal to 4. If it is equal, it is said to be linear. If it is not equal, it is said to be non-linear. And then the next classification, we need to find out whether the given system is static or dynamic. Whether the given system is static or dynamic. For static or dynamic, we need to substitute 3 different values. One as past value. Let me take, so here it is n. So let me take n is equal to -1, n is equal to 0, and then n is equal to 1 future value, that is 1. Okay. So here y of -1 is equal to log of x of minus 1, and then substitute n is equal to 0, y of 0 is equal to log of x of 0, and then next n is equal to 1. So, y of 1 is equal to log x of 1. So, static means the system, it should depend upon only the present values, Dynamic means the system will depend upon past and future values, past or future values, or past and future. Okay, and then for causal it depends upon present and past. Present also it can have, past also it can have, or present and past combination also it can have. Non-causal, if any terms becomes future, then it is said to be non-causal. Okay. So, for that only we are substituting three different values, one as past value, one as present value, one as future value. When I substitute minus 1 in your output, check your input function, only the x of functional values, you need to check. Here also minus 1, here also minus 1, both are same, hence it is called present value. It depends upon present input, and I am substituting 0, n equal to 0, I am getting y of 0, here also the same value I am getting x of 0, so it also depends upon present value. Similarly, future value, y of 1 and x of 1, both are same, it is said to be the present input. Okay. So, you can conclude that the output depends upon present input only. The output depends upon present input only. Hence, only present means you need to say that it is static. Okay. Hence, it is said to be static system. Similarly, when you see causal, if it is present, I can say that it is causal. Since the output depends upon present input only, I can say it is static system, and also I can say it as a causal system. Okay, it is also called as causal system. So, 3 classification is over. So, it depends upon present value alone, so it is called static. Since it depends upon present, it is also called as causal system. The next classification, we need to find out whether it is time invariant or time variant. So, for that what we have to do, we need to delay your input by k seconds. Okay. So, your first step, we need to find out output due to input delayed by k seconds. We need to find out output due to input delayed by k seconds. So, wherever you have input, you have to delay it by k seconds. So, I have x of n here, x of n will be delayed by k seconds. So, x of n minus k, I can denote it as y of n comma k, or I can denote it as y of n minus k. This equation I can represent y of n comma k or y of n minus k. This is my first equation. The next step, output delayed by k seconds. First step is output due to input delayed by k second. Second step, output itself delayed by k seconds. So, what you have to do means, wherever you have n, you have to replace it by n minus k. So, in the equation y of n, it should be replaced by n minus k, and then log x of, again n you have replaced it by n minus k. Now, verify whether first equation is equal to second equation. Yes, both are having the same terms in the right hand side. So, first equation is equal to second equation. Whenever both are equal, it is said to be time invariant system. Therefore, the system is said to be time invariant system. Okay. And then finally y of n is equal to log x of n. Okay. So, whenever I have to determine, that is whenever x of n is greater than 0 and less than infinity, I need to check whether I am getting y of n is greater than 0 and less than infinity, meaning that when I supply bounded input, I should get bounded output. Okay. So anyway, I am saying that this is bounded input. Whenever it is bounded input, definitely my y of n also will be bounded. Okay. So log of any finite value will give finite value, hence the system is said to be a stable system. Okay. You should not substitute 0 value, okay, and then negative values. Always your x of n should be a finite value. For whenever my x of n is finite, definitely the whole function also becomes finite. Therefore, y of n also becomes finite, hence the given system is said to be stable system. Okay. So write a statement that when x of n is finite, okay, or bounded, you can write your statement as when x of n is bounded, y of n is also bounded. Okay. When x of n is bounded, y of n is also bounded. Therefore, the given system is said to be a stable system. The given system is said to be a stable system. Okay. Thank you students. Thank you for watching.